So this will be our
inventory.
Right.
Yep.
Yep.
Ladies and germs, we are back again, and we've been asked about this several times, so I thought I'd take a moment and show you. This is the LRI process for blueprinting a Remington bolt, and I got a little ahead of it here, so I'll just walk you through it. We throw the fixture in the machine, and then we hit cycle start, and this here is literally just a old broken 1/4 inch carbide end mill, or 3/16 actually, that I threw in an old holder that we don't use anymore, and it comes in and just establishes a height. Then we slide the bolt face up to it, and we lock down the fixture, and that gets us all caught up to where we're at right now. And all this does is just get us a rough cursory height, so that the probe basically knows where the part is, and it can go find it and refine everything from there. So with that, we just hit cycle smash. The probe comes in. And of course, I got a phone call I got to take, so I'll restart this video here in about 5 minutes. Alright, so we're back again, and yeah, got done with that phone call. So, pick it up where we left off. The probe, now it's going to come in and start going to work. Spin it up and bounce off the face. And from here we're going to do what's called a vector probe routine. Since we can't hit all 4 sides because the lugs are in the way, we'll hit 3 sides and establish center. Then next thing from there is we hit the lugs, and what this is going to do is put an incremental move in and rotate the C-axis to get the lugs parallel. Then from there we'll come back and hit center again, just in case there's any shenanigans going on there. And once we do that, we're going to hit it, same vector probe cycle, but the mirror image of it. And that's just to double check that center is actually center. Then from here, what we need to know is exactly where the pinhole is for the ejector. So what we're going to do, come in here and we grab this guy, which is just a gauge pin, and then we ground a taper on the end of it. We drop that in, and the probe will come back. Now we're going to hit on that. And this is what kind of makes some of this stuff interesting, is in a perfect world you would rely on, you know, we're basically doing third-party manufacturing here. And anyone with experience will tell you that Remington, while they did they sucked. And we all know why. That's why they're out of business now. But the fact of the matter is, they made parts. Not everything was where we might like it to be. So rather than me modeling all this and then assuming everyone is on position, that is why we're using stuff like this, to where we can come in and qualify individually. So like all this first probing on the bolt body, we would write that to say 1 work offset. Then the gauge pin going in there writes to another offset. So those sets of numbers always run independent of each other, so regardless of how bad they screwed it up, we can always find it, and it's always repeatable for us, for this application, to come back and be able to do the work that we're going to do. So now we're done with that pin. Now we're going to start looking for stuff as it pertains to the M16 Extractor install. So we'll come down and we'll hit off the nose of the bolt. And we're going to find center. Once we have that, we're going to hit the top. Now here, we're taking another number, finding center. Then we're going to hit the top, and that's where the pin goes. So again, we're running on a different offset for each one of those, for a total of 4 offsets used for this operation. Now that we're done there, we'll come back to our original one, and we're going to cut the face on the bolt. What we're doing now is boring the ID so that we can accept the bushing. We're not actually hitting the face of the bolt yet. We're going to save that for a little bit later. And what we got here is a thread mill. And what it's doing is coming in, and we're actually threading the nose of the bolt so that this bushing can be installed. This bushing is threaded to the same pitch, and we'll screw that in there. And that's how, and then I'll show you the next step, what we'll do. And while that's running, I'll go ahead and clean off the window here because it's full of coolant boogers. That's a little better. Should be about done. Actually, it's doing a cleanup pass. We run it twice. What we'll end up doing here is threading this in, then we'll sterilize it. Then we're going to come in with this guy, which uses magnetic induction, and we're going to warm up just the nose of the bolt and the bushing, so that we can hit it with some flux and a low temp solder, and then we'll solder this bushing to the nose of the bolt and avoid using any direct flame so that we don't have any carburizing effect and we're not overheating the bolt, causing a change in the heat treat condition. And then once that's done, you let it cool off, and then we'll come back in and machine the ID for the appropriate cartridge that we're going to run, and then go on and do the cursory work with installing the extractor. So that's all finished. You can see now we got threads in there. Now we'll grab the bushing. And we'll just make sure we can screw it in. And it threads in nice and easy. That's good. And currently I'm out of brake clean, so I gotta go grab a fresh can of it. We'll hit it with some non-chlorinated brake cleaner. We'll spray the part. Get it nice and clean. And we'll blow it off. Here we're just going to wet it down with flux, and this is going to require 2 hands. Caleb, come here. So I got a live video going on. Go ahead and smoke that thing and install it. So hitting it with magnetic induction, like I said, it's produces the heat without the direct flame, so that we're not damaging anything. The solder draws down in the gap, fills the void, and that is just, in my opinion, the more cerebral way to do it versus trying to glue shit together with epoxy. Because between the, you run these guns hard, they get warm. Now that it's hot, we'll give it a squeeze and pull it down tight so the threads are loaded. And we just got to grab a pair of pliers so we can lock it down properly. And give it a pinch. You guys probably can't hear it, but it'll make a squeak sound. And there you go. And the reason why we make them a little proud is just so we got something to grab onto with the pliers. And then from here, because I'm a lazy individual and we don't want to hit it with water and create a cold joint, we just put a fan on it at low RPM and rotate it around to get it back down, not quite the room temp, but pull the heat out of it so that we're not sitting here all day waiting on it. But like I was saying, between the shock of firing the gun, the exposure to chemicals when you're cleaning the gun, and then any heat that might be transmitted into the bolt from firing it, say at a competitive event where you're just going rapid fire or a prairie dog town or whatever the case, all of that just creates a really, really hard environment for a glued in bolt bushing to have any chance of survival. Whereas a soldered joint, ever since we've been doing this now for a few years, well, we've been doing this now for about 6 or 7 years, we haven't had any problems with it. So from here, what we're doing is just machining it flush to the face of the bolt. And we're using all the numbers that we stored in the probing cycle earlier. Once we're done there, we'll come in and ID bore it. And here we're actually taking a whisker pass off the face of the bolt as well as part of the blueprinting operation. Pause it real quick. You can see that's what we're left with. So everything's in good shape. Now we're going to come in with the detail work and just chamfer the nose. That just puts the edge brake so that if the cartridge isn't quite aligned, we're not jamming it up when we're feeding. What we did there is just a clearance feature for the dual ejectors. Now we're coming in with a center drill. And a pilot drill. Now what we're doing here, we came in with a center drill to get the hole started. Then we came in with an undersized drill and pre-drilled it. Now we're coming in with an end mill, and we're going to interpolate that hole and get it started for the first few diameters, because we've got a pretty long-winded spaghetti noodle drill that's got to come in there, and we want to have it guided as best as possible. Because as you can see, that's, well, now you can see it. Small diameter, very long, and it's through coolant. You can see we're pushing coolant through the hole, and what we're doing right now is chasing the existing hole, just making sure it's not undersized, and if there's any solder that drizzled down into the hole, we're clearing that out. Then we'll pick up, and now we're going to poke the hole for the second ejector. And the whole intent behind this is an M16 extractor on a Remington puts an ejection angle on the case where it has a high potential to bounce off the scope, especially on the windage knob upon ejection. Adding the second pin restores it back to the horizontal trajectory so that the gun will function as standard. If you install the pins with the springs unaltered, it will increase the amount of effort it takes to close the bolt. So what we do is we trim a few coils off of the spring so that it, just so it feels normal again when you're running the thing. Now that we're done there, we're going to come in and start machining for the extractor. And the beauty here is we've only set this bolt up in one fixture, and because we can present it in multiple fashions to the spindle, it really goes a long way to minimizing tolerance stack or positional errors. We've had a really good high degree of success doing it like this. And the fixture is set up in such a way that when it's all finished, we can prove that it works without pulling it out of the fixture, so that, you know, if a tool's worn or happened to break and we didn't catch it, because I'm not always standing in front of the machine when it's running, we can address that issue and go back and remachine the same part with the same offsets, and we don't have to set the job up a second time. Pause it for a second. See there the machine work? You can see right up in the nose there the interruption on the threads where it's soldered in. And now we're going to come in and do the spot face for where the pin goes. And that same center drill comes in, and we'll just get the hole started. Okay, so the M16 part is done. Last but not least is truing the bolt lugs. And this will be like unlike anything you've ever seen, because normally this would get done in a lathe. And the whole issue that I've always had with doing this kind of stuff is imagine doing this in the lathe. So you take a face cut, then you take another face cut. Maybe you do this with a boring bar, but down here you definitely have to use a boring bar. So there's one tool, potentially two. You might do this with a turning tool instead on the face of the nose. But now you got to cut the back side of the lugs. That requires a tool change. Anytime you have that, you have the risk of stacking tolerances, which we have the same thing here, but the difference is all of these offsets are preset in the machine, and they're all qualified off that guy right there, which is a tool probe. You bounce the tool off that stylus, kicking out in a little L shape there, and it stores all the information required on that tool right here in the offset page. So what we're going to do now is cut the bottom of the lugs. Again, same setup, same operation. We know we're square. So we take a whisker pass off the top. Drop down and do the same thing on the bottom. And whether you run one bolt or 100 of them, they literally become interchangeable with the receivers. So there you can see everything's done. The machine work is clean. I got a little tiny burr right there. Well, actually it came off with my fingernail just picking at it. And then from here we just grab a cartridge. Qualify it, make sure it fits in the bolt, make sure it'll fall in there. And we just grab an extractor. These are the ones that we make in-house. And we get a spring. A spring, not 3 of them. And last but not least, a dowel pin, but I do believe we've got a checker pin here. Here's what I was talking about. It's a little tight on the sides, so that tool has got to be comped a little bit. So we go back in here and we reset the program. And we'll just put it in edit, and we'll page down, get past all the probing. So we're looking for 7804. So we just go to list program, go home, go over to memory, page down to 7804, and select it. That's the drilling operation. I'm going to need both hands to do this, but it illustrates the point, how we do it, and all I got to do is pull that program back up and just run this slot and comp the tool a little bit, and then we'll be in good shape. So I'm going to go ahead and jump off and do that, because I think you guys get the idea, but we've been asked for a long time to show how we do this, and just never had the time, but end of the day, figured why not. So, as always, thanks for watching, and we'll see you again.